All right, James, over to you.
Thank you very much, Lorelli. Good morning, good afternoon, everyone. Thank you for taking the time to attend this webinar presentation. My name is James Nyik. I'm a solution engineer. I work primarily with federal civilian clients. So a lot of US government type entities are my customers. And one of the favorite features and capabilities of the Hashi stack that they enjoy using very much is this capability we call Sentinel. So today I wanted to cover a few basic items, just an introduction really to what Sentinel is and how Sentinel is used specifically around Terraform Cloud, which is our hosted HashiCorp platform infrastructure building capability. So I wanted to begin just with an overview. You know, what is Sentinel? For those who are not aware, have never come across it. Is this some kind of new HashiCorp product, HashiCorp solution that is out there, and you know, maybe give people a sense for what that's all about. So I'll first start by saying Sentinel is not a separate packaged application that you download from or pay for from HashiCorp. You cannot really take it and deploy it independently. What it is it's a framework. And it's a framework and a capability for performing governance policy type actions within Terraform. It's actually used within HashiCorp Vault. It's also used within Consul and Nomad as well. So it is actually a modular framework that is built into the enterprise solutions that we offer. And basically what it allows you to do is encode as code policies that you would like to enforce in your infrastructure building processes. Maybe in Vault, you might be controlling access and to resources. Same thing in something like Consul. And in our last product, which is Nomad, you'll see Sentinel being invoked to sort of control the types of resources and applications that are being deployed. So it's got its own language. So it has a way for expressing those policies that you'd like to encode. And again, it is something that is really embedded within the enterprise solutions. You don't really see this on the open source side. Now, the beauty of Sentinel and the reason for its existence is to really ensure that various governance type policies that you may want to enforce in your provisioning processes get checked and are actually being enforced rather than simply remaining on a list somewhere within your organization, right? The idea that it can be fine-grained, that it can use conditional logic to compare attributes makes it really, really powerful, right? Very much like, you know, Turing complete code might be able to just about build anything. Now, it also does include a CLI that you can download. A lot of this is available on releases.hashicorp.com, and I'll provide some of these resources to you, where you can actually mock and test out these policies before you actually deploy them. Now, there are multiple types of Sentinel policies, but I would say, you know, we think of them really in sort of 4 categories: policies that are restricting specific attributes on specific Terraform resources that you might be deploying on your current plan. It might be restrictions around configuration of Terraform modules, variables, resources, all of these things. Or you may want to check what the condition of certain previously provisioned resources might be, and maybe they contain values that are no longer valid, or you want to control and restrict. And then finally, being able to check the very workspaces which are only existent in enterprise, that, you know, that certain metadata, cost estimates are within certain limits, right? And you don't have to just use one policy on a workspace. You can use multiple policies. Where are these used? So in Terraform, specifically Terraform Enterprise, these policies are checked right after the standard plan or apply steps are performed. So if you're familiar with a standard Terraform Enterprise workflow, it begins with a planning stage where it reviews and examines your infrastructure's code file, makes a determination as to what it is you'd like to build for resources, and sets up a plan, understands all of those things. Right after that, it typically will perform a cost estimation. So it'll use that native cloud provider's API, if it has one, to determine what is the cost of these resources you're about to deploy, and returns that information to you. The next step is where the policies are applied. And these policies essentially are encoded as a set of rules, each of which will be evaluated against that plan information, that workspace, that environment, those variables, and all of those things will be subject to the policy. And then that policy will have a number of different enforcement levels that it puts to bear. Those might be an advisory, as we call it, soft mandatory, or a hard mandatory. And I'll explain a little bit more in a few slides what that means. Any violations of the policies may or may not prevent that apply from continuing, right? And it may actually require that you have someone with the appropriate authority to override the policy failure or violation and to move ahead. These policies can evaluate the attributes, that's the arguments and exported attributes on resources in the particular run that you're performing, right? But the key is the policies are trying to prevent either a bad provisioning flow or a flow that is not allowed based on governance rules that you have in place. Now, as important as it is to say what Sentinel does, it's also important to understand what it does not do. Sentinel is not a monitoring capability. So it's not telemetry. It does not check on your infrastructure continually to validate that it's compliant. So there's plenty of tools on the market that do that well, you know, from your Grafanas, your Telegraphs, your Splunks, that can do all that monitoring. But policies that use a specific type of import, which we call the Terraform state import, could be triggered periodically, maybe using an API call, to perform some of these types of continual checks on running infrastructure. And why would you want to do this, right? So think about a scenario where perhaps in your organization, you do allow people to make changes to your infrastructure through Terraform, of course, but also through a command line interface, or through a CLI like an Amazon CLI, or through the Consul that is offered by a cloud provider. So if you have that situation, you have one or two ways people could introduce change or drift, as we call it, into those environments. And so you may want that policy to keep checking for certain things such as this. Sentinel does not remove resources that violate policy. So it is purely a notification or a mechanism for being aware that things are changed, but it is not a remediation mechanism. So if you understand the Terraform workflow, what you should really do is, if you notice this drift, if you notice there's a violation in policy, you change your infrastructure's code files to either a new configuration or to correct and mitigate the violation of policy. It does not ensure that resource attributes are valid. Only you, as the writer of that infrastructure's code file, is aware as to whether the resources, the attributes that you've put in are valid attributes. So if you put an incorrect attribute for a cloud provider, say KMS key, Sentinel won't know that that has happened. That is outside the scope of its capability. It does not look into the resources that are stood up. So it cannot know what's in an AMI or an image or a container or a virtual machine that is being stood up, right? It simply governs the provisioning process by looking at what you are asking for as a target end state when you specify that infrastructure as code file, and then will give you feedback on what is happening there. And it also doesn't limit any kind of runtime action that those deployed applications are performing. Once you deploy a web-based application, for example, using, say, Terraform to stand up the infrastructure, maybe Ansible follows up and deploys an application, whatever that application does, that application does. Sentinel has no role in that environment. All right, so where do we typically store these policies? So we typically do store them in a version control system. Git, everyone's favorite version control system, is probably what you would be using today. There is a facility, and I'll show this in some of the demo, for putting these policies into Terraform Cloud directly, although that is now deprecated. I will use that as an example just to demonstrate how these things are written. Now, the benefits are really all the usual benefits of VCSs, right? The fact that, it's your historical record. You can go back to the past or an older policy, reinstate it, all of these wonderful things. The sharing capabilities of having a version control system are self-explanatory. You don't have to have these policies used by only one stakeholder organization. You can spread the love, so to speak, everywhere. And then you want also some control around these policies as you make changes to them, so you can take advantage of pull requests and all of these sorts of capabilities when you put them in there. A commonly asked question is, how are customers using Sentinel in Terraform Cloud as we roll it out throughout the government and the enterprise? So the number one request is, of course, really around enforcing, security and various governance standards, right? You see a couple of things there. Many of these are restrictions, right? Security teams, operations teams, governance teams want to have some kind of control around what is enabled, disabled, allowed, not allowed within the infrastructure that they're provisioning. So that might be making sure things like buckets, S3 buckets, are made private, controlling and restricting ability of roles that can be assumed if you're using AWS, and then certain resources you just want to prohibit, right? The second is really around controlling cost, right? Because as you provision and you provide, a self-service capability throughout your organization, you kind of want to be careful about what the implied costs of that kind of lack of control could be. And it is actually very expensive if you have to have people involved in the process of validating and verifying that all infrastructure that is being built is actually being built according to policy. So why not use something like a Sentinel that can proactively, ahead of the provisioning process, decide that, infrastructure that's going to be built does meet policy or does not meet policy. And that includes things like limiting sizes, limiting the kind of monthly spend that you might have involved whenever you do this in Terraform Enterprise. I have a story here. I myself actually took a random piece of code, infrastructure as code, to stand up a Windows machine off the web when I was learning. And I put it into Terraform Enterprise, and lo and behold, I happened to have a standard set of policies in place, and they caught the fact that I was just about to stand something up that was going to cost me about $1,500 a month. So, you can begin to catch and stop mistakes of this kind. The third is really around tagging. It is hard to overestimate the number of times that people deploy and provision infrastructure and teams come after the fact and have no idea who that infrastructure belongs to, what it was stood up for, how long it's been around. And so this idea of tagging is really, really important. And you can enforce that through Sentinel. And then finally, the choices around what modules are being used. If you take advantage of Terraform Enterprise or Terraform Cloud's private module registry, and just coding conventions, right? Which is a good way and proper way to write these things. So when you use Sentinel within Terraform Cloud, there are two entities that you use to create and deploy these. The first is the idea of a policy set, which is just a grouping construct for Sentinel policies, right? You don't want to do one policy at a time. You want to perhaps logically group these policies, say, to be cloud agnostic. Maybe some are repository related, some are cost related, some might be pure security around the network related, some are credential related. So policy sets act as a way to group these policies in such a way that they can be applied to one workspace or all workspaces. And I'll show you some of that. So you would, they're created in these version control repositories, typically in Git, and then registered into Terraform Cloud using the user interface or an API, right? The nice thing with these policy sets, and as you configure them, is that you can control whether you're going to have a single repository and the policies are maintained in branches within that repository, or they are perhaps maintained within folders within that repository, right? So you get an option of some flexibility there. Sentinel is also a little bit more flexible in that it allows parameters to be added to policy sets, allowing you to invoke a more custom type of behavior. So for example, if maybe you need to invoke an API endpoint, you might want to include that URL or include some parameter that gives you the right information back. So a little bit about those policy enforcement levels we talked about. So there are really three levels that come out of the box with Sentinel. The first is an advisory level of enforcement for a policy. This is just saying that if that policy is violated, Sentinel will just log the message and let you know, hey, someone violated, or this particular rule was violated. No other action doesn't prevent the building of that infrastructure. The second is the soft mandatory, right? So the soft mandatory simply says that there is enough of a violation here that you actually need someone else with the necessary permission to come and override this violation and allow the apply process, the building of that infrastructure, to continue. The third is what we call the hard mandatory, which is actually the default enforcement level, and the policy must pass. If it doesn't pass, the only way to remediate this is you either explicitly remove the policy or you change your infrastructure's code to be in compliance with the policy. So a little bit about how Sentinel works. Where does it work, and how exactly does it work? So we talked a little bit about this. You have your version control system that contains your infrastructure's code files. It may also, in a separate set of directories, contain your Sentinel policy code as well. So the typical flow you would see without Sentinel, this is typically what you have with your command line open source, is your infrastructure's code files are fed to Terraform. You run the plan and apply, and you get your infrastructure. Now, if you have Sentinel in Terraform Cloud, it's slightly different. You have the version control system just like before. You have your workspace in Terraform Cloud that performs the plan. It actually does the cost estimation right after that. And then the Sentinel policy checks are applied. If they pass and you have no hard mandatory failures, then the apply can continue and build your infrastructure. The addition of this single step is where you get that governance and control. The way this looks in Terraform Cloud is very similar to this. you would see those 4 steps as shown, and highlighted in green is where you can see an overview message of the policy checks. You can see how many policies were checked, how many passed, and how many failed. And we will look at that a little bit more shortly. Okay, so I've talked a lot about policies. I've talked about them as being code. So let's take a look at what these policies might look like. So first of all, a Sentinel policy is code. And one of the things that it needs is an import. So it needs a couple of helper functions, helper libraries, constructs, data structures that it can take advantage of as you write it. These are the standard ones, right? The ability to, HTTP there is the ability to make actual HTTP calls out. This is perhaps where you might want to reference a table or get some JSON data that might be used within that Sentinel policy to actually evaluate against a threshold or a set of values. You have your SOC adder import that might help you manage requests that were made as part of that build. And then a lot of your plan information is a lot of strings, right? And numbers and values. So the strings and the JSON pieces together can just help you look at each of those attributes, those pieces of data, and then do a comparison. And so each Sentinel policy is essentially of this form. So we talked about the standard libraries that you can import. If you have additional reusable libraries you want, you can import them there. So this might be importing a different set of Sentinel libraries or rules. Then you will require a main rule at the very end that has to be evaluated. So you can see here written in blue, there is the main rule, and it evaluates a set of conditions essentially to determine, do I get a result of that rule being true, that condition being true, or that condition being false? That decision of whether it comes out true or false is what determines whether the policy has passed. You also have the ability to set up variables. So those variables can be hard-coded values. It could be values that are pulled in from, say, an HTTP source, and you pull in some values that you may want to use at the time that you're evaluating the rule. So every Sentinel rules, every Sentinel rule in one way or the other looks very similar to what you see here. So let's look at a quick one, and I've actually prepared this ahead of time so that we can see it in action as part of the demo. So if you look at the very top, there's an import statement for this policy, which is supposed to restrict the size of an Amazon instance that's about to be built, right? So at the very top, you can see an import statement and an alias, right? So it says import this reusable library that can look at the Terraform plan information, and we'll call that TF plan. Right after that, we have a variable that's been set up. It's called allowed sizes. So this is defining the size of this particular AMI that we allow as part of this policy. We don't allow anything other than a T2 micro, which is just a size of EC2 instance or virtual machine in Amazon. Right after that, you can then see a filter statement. So what is happening here? The details are not necessarily that important for this particular webinar, but what you're seeing now is we are filtering through that plan that has just been run prior to the evaluation of this policy. And we're looking through resource changes, right? And we want to find resource changes that contain create or the words update around, of type AWS instance that are managed, right? So what is important to take away from this particular statement here is we receive a Terraform plan. We have our decision of what size we're going to allow, so our threshold, which is the T2 micro. And now we filter through looking for anything that we know would have that T2 micro applied to it, right? Or would need to compare against. And then we are saying that we want to set up a rule that all allowed sizes must match T2 micro, right? And if we don't have the matching that, then the rule will fail. And if it fails, we cannot move forward. Okay, that's essentially what this rule is saying. Now, I ask that don't be surprised if you're not able to read and understand this immediately. It's really critical to understand that it takes time to learn how these things are written. Many times it's rare to find, in my opinion, that you're writing them from scratch. We'll talk a little bit about what are called foundational policies. We have a lot of internal examples that you can actually take, and leverage and cut and paste and modify and give you a head start. It takes time to get proficient at this. Hard things are hard, but there's tremendous benefit to be obtained from this. So what are the sample use cases where we see it applied? So some of those around security standards. This is what we typically see. This is some of the most common. All S3 buckets must use a private access control list, right? So what does this mean? It means don't set up storage in the cloud and leave it open to the rest of the world, right? This is like #1 mistake probably in the cloudscape, right? Machines that are sitting out in the open and easily accessible are targets for hacking and brute force attacks. The roles that an AWS provider can assume, you don't want to give it too much power, or you want to control what roles are allowed. You want to control and prevent which resources and providers or data sources are being used as part of infrastructure builds. Around audit tracking, right? We want to know who's doing what, right? So we want to allow deny certain operations based on team membership. Overrides can only be performed by certain teams. And you also want to control around, things around the review of an audit trail to cloud operations teams. And then resource restrictions, right? These are the most common things. I want to limit the size of that virtual machine, the cluster cost, the tagging we talked about in the modules. All right, so let's jump into a little bit of a demo here. I'll just go over and show you how some of this works. So I'll begin by actually showing you my repository. Give me a second here. I'll make this a little bit bigger. So what you're looking at is I happen to have a Git repo that contains a number of folders. And within those folders, I have a whole bunch of different examples. Actually, all these .sentinel files are Sentinel rules, right? So I'm going to open one of them here. So this is a Sentinel policy that is basically evaluating total monthly cost and percentage increase in the monthly cost that would be incurred with a particular plan, right? This is, for example, very good with any cloud provider. It's actually a cloud agnostic one. And you can see the elements here, right? So you can see an import of a function. You can see another import there. You can see a couple of variables being set up. And then this is the actual increase, the cost validated test. And then this compares your max percentage or limit with whatever the run is going to provide, right? So now it's great to have a single rule like that, But what you really want ultimately is you want many of these conglomerated into one single HashiCorp configuration file for the Sentinel pieces. And so this is how you would do it. You would simply put a line items like this, which gives it a name, right? This is where now you're pulling to, these are the various models that you're going to be using. Here's your policy. I want to use this policy. I'll call it that. This is the source. So it's just one, in that same directory, a particular folder. I want this Sentinel policy to be enforced at an advisory level. So I'm putting together, I'm grouping together many, many different policies that I would like to apply as a unit. Okay. If I go over to my Terraform enterprise side, this is Terraform Cloud. I happen to have a workspace where I have plenty of different workspaces that I use for my demos. Today, I'm going to specifically target one particular example, which is an AWS EC2 instance builder, right? And the way I've configured this entire organization where this workspace exists is I've set up a number of policy sets. So I have many policy sets that I use. I actually am pointing to that repository, this repository that I just showed you, the cloud agnostic one. I'm referring to that from within this policy set. So I'm just going to click into it. And I'm going to make this a little bit bigger for those who may not be able to read it. And so what you can see here, it has a name, whatever your description that you want to give it. And it is linked to that repository. And I actually gave it a specific path. So I mentioned that you could use branches or you could use specific branches or specific folders or paths. So I use the path-based approach. So my branch is still master, but my policies live in this folder called the cloud agnostic folder. And in there, it's going to look for that sentinel.hcl file, which is the aggregation of all the policies that I want to put under this particular title. The other thing that I am going to do is then decide what is the scope of these policies. Are they going to be applied on selected workspaces, or are they going to be applied globally throughout everything? So in this particular case, I'm enforcing it on specific workspaces. I've selected my AWS EC2 instance, right? I have no parameters right now. If you had specific parameters, you could actually supply those at this point. Okay, so that's my policy set that has been set up. And remember, policy set was simply a grouping of these policies. Now, I also wanted to add one more policy, which is the one I gave you as an example, which restricts the size of an AMI. Now, entering direct individually managed policies like this one is actually deprecated moving forward. So you're going to have to be creating policy sets and putting them in a version control system and reference them that way. So don't do as I am doing here. Simply use this as an example to understand how these things, they can work, right? And how we traditionally used to do this was you would just type it directly into the user interface here. This is the exact same T2 micro example that you saw previously. You can control the enforcement levels here, whether I want it hard, soft, or mandatory. But if you put it in Git, you just put a line that indicates your enforcement level, right? So I hard-coded this in, and then I tied it to the same Sentinel policy demo policy set so that I group that together with my cloud agnostic example pieces. Right, so that's the setup. That's how you bring the policies in to Terraform Cloud. How do you actually see this being executed and evaluated? So if I go back to my workspaces, I go over to my EC2 instance workspace here. I'm going to start a new plan. Just going to call that my Sentinel demo. And what I've done now is I've kicked off the building of this particular piece of infrastructure, which is a single EC2 instance. I don't have automatic building set up for it. I want it to stop just after it's finished the policy build. So here you can see the plan has been performed. So it's looked at my infrastructure as code, understood what I'm trying to stand up, and is beginning to perform the next set of actions, which are really going to be that cost estimation and the policy checking. So it's just finishing that off. And now the next step is it's calling the API and discovers, okay, you're going to have an increment of about $8 and change on your bill for this particular piece of infrastructure. You can see that that's one AWS instance. Use the API to find that out. And then the policy checks have occurred. Out of 15 policies, most of which are actually in that policy set that is cloud agnostic, and including that additional one, 2 have failed. So let's look at the details here. So the very first one is my restriction on AMI size. It just so happens that this is only a T2 micro example, so that particular policy is passed. Now, when I look at the other policies, such as, am I using prohibited data sources or providers? All these pass except the limit cost by workspace name has failed, and it was marked as advisory, and also require all resources from the private module registry. All my resources for this particular build are actually in a Git repo. So that is why this particular one failed, right? But everything else is pretty much passed. And if you want to see some of these details, you can actually see which rules exactly were executed and the value that resulted from it. And now all that would be pending is for me to confirm and apply, and it would actually go ahead and build the infrastructure. I'm not going to bore you with seeing all that, but essentially that's what you get. So I'm just going to discard this run. Okay. So that's the demo piece. Just want to finish up a little bit here so that we can get some of your questions in. Some best practices on using this. We have a set of foundational policies. I recommend you start with those. These have huge impact. Things like tagging can bring many benefits. Another good practice is set your policies at the advisory level, right? Before hardening and forcing people to actually change things out. This gives people time to get familiar with things, just get comfortable, and you know, it prevents any kind of resistance to using this. And then you really have to develop the proficiency in writing these policies if you want to become really good at them and extract the absolute maximum from this particular orange, right? You will get a lot of automation benefits if you're able to do that, but this is an organizational choice that would have to be made. If you want to learn more about this, there are various resources. If you just did a search on the web for HashiCorp Terraform Foundation policies, you'll find that library. These are 50 policies or so based on CIS benchmarks for various types of environments, and they cover the most common cloud providers, you know, folks are probably using. If you want to go through actual exercises, Kata Codas are particularly good for this. It helps you build a policy, make it more complicated, adding mock data, and then testing and writing them out. So this is a fantastic resource for that. And, you know, you can take a screenshot, or, you know, Loralee will also send this out to all of you so that you have access to this and to this presentation, and you can take advantage of it. And that's what I had for today. At this point, I'd love to take your questions, see if I can guess where the answers might be. If I don't know, I will point you to the appropriate location where you can find them. But I'd like to sort of open the question here, Lauralee, to questions from the audience. Anything in the chat that perhaps I could answer?
Hey, James, thank you. That was a great session. I don't see anything in the chat at the moment. It looks like you answered the one that we had in there.
Okay. Yeah, I'll just give some personal anecdotes here around, and a couple of points that I think are really important. One of the typical questions I get is, can I use existing policy frameworks that I have out there and just use those, or rules engines that are out there and take advantage of those? And the answer is not today. Typically, our customers will either use our foundational policies and bring those in. Some will rewrite the existing policies they have, especially where they feel the Sentinel Policy-as-Code language is a little simpler to understand and to maintain. So there is a hurdle there. There is a challenge. But it's really a matter of comparing and evaluating what your current organizational skill set is, so that you can determine whether it makes sense for you to simply rewrite them in HCL or not. Not everything is put into these rules. There are some things that make sense to put in there. I think if you think about the different events that consume the time of your security and operations or network teams, are there things in the activities they continually are asked to do over and over with every infrastructure build that you can just make, if you have a heuristic or a general rule that you can encode as a Sentinel policy, it's a good idea if you're a Terraform Cloud or Terraform Enterprise user to consider just encoding that. The real benefit there will be in the time that you're going to save meeting, having change control boards or whatever it might be to discuss whether teams followed the rules as they built infrastructure. So it's really important to be aware of that. Okay. So that's all I had. Any other questions?
We are getting some questions in the chat. The first one that I see in here is, what is the difference between org and Sentinel policies?
So an organization in Terraform Cloud is simply a way to organize workspaces. Think of it as a folder that has a name. It could be a functional name like developers. And then in there, all the workspaces are groupings of infrastructure that belong to the developer team. Some people name organizations based on a function. Could be for, I don't know, for marketing teams or for data analysis and AI teams or something like that, right? But, the policies are not directly related to the orgs. What you do is you set up policies within the organizational construct so that it applies to either all the workspaces within that organization or only selected workspaces within that organization. So one is really the actual policies. The other is just a way to organize the infrastructure that is going to be run for that grouping. I hope that answers the question.
Cool. All right, another one. For medium to large companies, what kind of RACI do you recommend to make the framework scalable?
Is that RACI, R-A-C-I?
Yes.
So for medium to large companies, I don't know if I have thought about it with respect to the RACI framework, but what I would say is you have to start with sort of higher level principles that organization has for the types of behavior they want to see. Someone needs to break that down and then say, all right, we need to have some level of accountability at the highest level, say within the IT department or within infrastructure building or whomever it is. So those folks in the leadership, I would say, need to be informed, right? Some kind of minimal report that could be created that would let them know that this is happening. With respect to accountability, I would say, Sentinel policies have to be coded. The person who can actually make changes to them or may have written them or may have modified them probably has a bit of a developer skill set. So that's where it's much lower down at the developer or technical person level that I would say there is the actual accountability and responsibility for those to occur. The rest is probably folks who just need to be communicated to and made aware that these things are being applied. I think that's my starting point. I don't know where it would end. It would depend on the organization, I think.
Great. All right. Is there an easy way to generate mock files for local testing other than running Terraform plans in Terraform Cloud and downloading them there?
There isn't, not that I know of. Not today, certainly, especially if you're talking about generating them. If you're truly doing this at scale, and you need help doing that, that's kind of where I would engage probably with some of our more experienced Sentinel team members who can give you some pointers on that. Because I know we have some customers who use a lot of these, and I know they were not deploying them and testing them in production or without mocking a lot of these. So my suggestion would be just engage us, and we can probably provide you some of the tricks and tips that make the process more efficient.
Great. All right. Which policies do you think should be implemented using Sentinel, and when to use native cloud policies?
Yeah, that's a great one. So if you're building infrastructure with Terraform Enterprise or Terraform Cloud, right, which this entire presentation presumes you are, there are a couple of things which I think are my favorites, which are anything that cuts across clouds, you should implement with Sentinel. So controls around the size of infrastructure, the counts of buckets, networks, virtual machines, whatever you might want, regardless of cloud provider, you should write in Sentinel. Tagging, really, really important. Tagging, you should write with Terraform Enterprise. The only things you should really write within a specific cloud provider's framework are going to be things that either only exist in that particular cloud provider's environment or have a peculiarity that is specific to that environment. So they might have an attribute that doesn't exist in any other cloud provider. So really put on that lens of commonality and look for, the things that are common, do in Sentinel. And I would say the things that only exist or are specific to a particular cloud provider, then you may want to add those in their particular policy framework.
Awesome. All right. The last one that we have is, could you speak for a minute or two about how Sentinel interacts with a tool like Vault?
So I'm not sure whether that question is asking how Sentinel from within Terraform might interact with Vault, or whether Sentinel is used in Vault and how does it operate there. So the only way Sentinel within Terraform Cloud would interact with Vault is by perhaps looking at some of the Terraform plan or run data, because Terraform you can write a Terraform infrastructure as code file that interacts with the Vault, and if you do that, some of that run data is available to actually evaluate with policy. So that's the only way within Terraform Cloud you'd be able to apply Sentinel policies to some of the outputs coming from the Vault or going into the Vault as you configure it. Okay, so that's with Sentinel running in Terraform Cloud, and Terraform Cloud is trying to do something against the Vault. Now within HashiCorp Vault, there is a Sentinel, the same Sentinel Policy-as-Code engine that is used a couple of different ways. it can be used to control role-based access. So it controls who is accessing the vault, and you can write very, very fine-grained policies. For example, I might write a Sentinel policy that would control access to a particular secret to be within, say, the weekend, only between noon and 6 o'clock on Saturdays when during the third week of the month, right? That might be only time. If I want to write something so fine-grained, I can use Sentinel to do that. The other thing that you can do is really this idea of either role-based fine-grained policy controls. So whatever role is trying to access a secret, I want really fine-grained control around it. Maybe it's a public role that I'm putting in place. That might be some place you would use Sentinel. The other is what we call endpoint governing policies. So this is actually a way of using Sentinel to protect the secret regardless of who is accessing the secret. So I write a fine-grained policy that says this secret may require additional information in order for that API call to succeed, or you can only be from a certain role in order to access a particular secret. So there are policies that govern a secret, and there are policies that govern the role that might access a secret. And that is how we use it within Vault. And that is above and different from Sentinel running within Terraform that might be interacting with Vault. I hope that's a little bit clear.
So he did add a little bit of to clarify. He said, we're looking to bring Vault in as an enterprise tool as well. And one of the tier features, paid Sentinel integration. He's just curious what that's about.
Yes. So if that's the second use case, which is really using Sentinel within Vault to write very, very fine-grained controls for access of a secret, or to control the types of roles that are accessing secrets, or to just control who is logging in, what IP addresses they're coming in from, all of those kinds of details. You can use Sentinel to control those factors.
Okay, that was the last question that was in the chat.
Excellent. So that's all I had today, Lauralee.
Great. Thank you so much. That was a great webinar. Thanks again to everyone on the call. Thank you for your time. I hope you really enjoyed it and it was informational for you. And I hope you enjoy the rest of the day. And like I had mentioned earlier, this is being recorded, so we will share that along with the slides out with all those who attended today. So thank you.
Thank you, everyone.